Good afternoon, sir.
Good afternoon, sir.
I'm audible.
Good afternoon, sir.
Good afternoon, sir.
Good
Good
afternoon,
afternoon.
sir.
I'm audible. I'm audible.
Yes, sir.
Okay. So now let us start the presentation. Here Ayush Kumar Mishra.
Yes, sir.
Okay. Are you ready for presentation?
Yes, sir.
Okay. Now you can start your presentation.
Okay, sir. Just a sec. Good afternoon, all of you. My name is Ayush Kumar Mishra of BSc first semester, and I'm here to present on the topic different types of programming languages and their purpose. The world has been evolving at an astonishing rate, and a solid part of the credit for that advancement goes to the application developers. In case you haven't noticed, application development has become all the rage in recent years. Everyone is trying to get in the application development scene as it offers some of the highest paying career paths, such as web development, data science, artificial intelligence, and more. But before one should start a career path and create their first application, they need to first pick a programming language. Now, what is a programming language? A programming language is a computer language that is used by programmers to communicate with the computers. As we know, to communicate with a person, we need a specific language. And the language that we use to communicate with the person is a programming language. Programming language is a language that is used by programmers to communicate with the computers. As we know, to communicate with the computers, we need a specific language. And the language that we use to communicate with the computers is a programming language. In 1995, JavaScript is a perfect option if you want your app to run across a range of devices, such as smartphones, cloud computers, cloud containers, microcontrollers, and on hundreds of browsers. What are the objectives of JavaScript? Application development, website development, game development, and VR development. The next language is C and C++. While C was released in the 70s by Dennis Ritchie, C++, an extension to C with classes and many other additions such as object-oriented features, was released later by Jan Stostrup in the mid-80s. Even after close to 50 years, both the programming languages are still being used to create rock-steady and some of the fastest applications of all time. Purpose of C and C++. Operating system and system tools. As C and C++ both offer full access to the underlying hardware, they have been used to create a wide variety of applications and platforms, such as system applications, real-time systems, embedded systems, games, clouds, and containers. The next language is Java. Created by Sun Microsystems, James Gosling in 1995, the object-oriented programming language Java has been serving as a secure, reliable, and scalable tool for developers ever since. Some of the features offered by Java that makes it more preferable than several other programming languages are its garbage collection capabilities, backward compatibility, platform independence via JVM, portability, and high performance. What are its purpose? Apart from being used to develop robust business applications, Java has also been extensively used in Android, making it a prerequisite for Android developers. Java also allows developers to create apps for a range of industries such as banking, electronic trading, automotive, healthcare, and many more. It is used for image processing and graphic design. The last one is SQL. Designed by Donald D. Chamberlain and Raymond F. Boyce in 1974, the special purpose programming language has played a key role in enabling developers to create and manage tables and databases for storing relational data over hundreds of thousands of data fields. Without SQL, organizations would have to rely on older and possibly slower methods of storing and accessing vast amounts of data. With SQL, much of these tasks can be done within seconds. Coming to its purpose, pretty much every other project or industry that needs to deal with large amounts of data stored in tables or databases uses SQL. SQL is also used to maintain the transaction occurring in the databases. SQL integrates with ease with two famous scripting languages, Python and R. After integrating, we can easily manage the database with these scripting languages. That's all for my presentation. Thank you all.
Okay, good. Just open your video. Okay, now close it. Now next, Prakash Chaurasia.
Yes.
Are you here?
Yes.
Okay, now you start.
Hello. Sir, there is echo. Wait. Yeah. Sir, am I audible?
Yeah, you are audible. But
Yeah. Hello.
just share your screen.
My name is Prakash. Yes, sir.
Share your screen.
Second, I have shared, I think.
But it is not visible.
So 1 minute.
Again try. Stop just, then again try.
Yes. So can you see it now? Sir, I am actually sharing from different account. No, you can see it. Wait. Now can you see it, sir?
Yeah. Now it's coming.
Okay.
Yes, it's okay.
So hello,
Analog
my
and
name is
digital computers.
Yes, sir. So, hello, my name is Prakash Chaurasia. Today, I'm going to present among all of you a brief discussion on analog and digital computers. So, computer, it's a beautiful thing, isn't it? But have you ever wondered how they work? Of course, you all are computer fanatics, so you all probably know how they work. Well, let us first start with digital computer. So the computer on which you are listening me is a digital computer. They convert data into bits, which are represented by zeros and ones. Today, most of the computers are digital computers. They are used by business organizations and many individuals. Reason being, these computers are very fast in speed and simultaneously they provide very accurate result. Then we have analog computers. Analog computers store data in a continuous form of physical quantities and perform calculations with the help of measures. Analog computers are the earliest computers. Today, they are largely replaced by digital computers. The same reason, because of their less accuracy and low speed. Here's the example of a very basic analog computer. It is used to add two digits. So if we have to add two digits, we move the black wheel by 5 units, and then we move white wheel by 4 units. So we can see the result in the gray wheel, which is moved by 9 units. This is a basic analog computer. Then we have the example of a basic digital computer. As you know, basic our digital computer takes inputs in bits. So there are two bits, so they represent 0 and 0. So when we add 0 0, we get 0. Then 0 plus 1, we get 1, and 1 plus 1, we get 2, which is represented by, of course, 1 0. So now let's see a brief comparison between analog and digital computer. Analog computer works with continuous values, while digital computer has discrete values. Analog computer has less memory, while digital has can store very large amount of data. Analog computer is less accurate in comparison to digital computer and is um, slower than digital computer. The examples of analog computer are thermometer, analog clock, older weighing machines, etc. And digital computer, we have the
Hello,
computer on which you are.
Prakash.
Yes, sir.
Prakash, your
Yes, sir.
slide is not changing. Your slide is not changing.
Oh. Okay.
Which slide you are discussing it? Yeah.
So can I do it like uh, 5 or 10 minutes later? I will like figure out what's the problem.
Okay, no problem.
Yes. Okay.
Okay, next one. Now we start once Saxena. Once Saxena is here. Once Saxena.
सर क्लास में नहीं है वो.
अच्छा वो क्लास में नहीं है. But he has given her name on my desktop. Okay. Next one, Vikas Chauhan.
Yes, sir.
Are you ready for presentation?
Yes, sir.
Okay. Now share the screen and start your presentation. ठीक है, पहले आप करिए फिर उनको चांस देंगे.
Okay, sir. Good morning, everyone. I am Vikas Chauhan and I am going to give presentation on topic disk operating system. It is commonly known as DOS. DOS stands for disk operating system. And DOS was the first widely installed operating system for personal computer. DOS controls the computer's hardware and provide an environment for programs to run. This system Now, the major tasks of DOS are to control input and output devices, to to enable use to load and execute programs to maintain an orderly system of data on the disk. DOS files. There are three important or special files are batch file, command file, executable file. DOS commands. DOS consists of a series of programs designed to control the computer resource. DOS command have three parts: file name, parameters, switch. Most of these commands consist of regular English words like word, for example, erase, copy, del, print, etc. Types of command. There are two types of command: internal DOS command, external DOS command. Internal DOS command are stored in .com file and are loaded automatically into the memory RAM when you start your system. These include the simpler and common command that are you need on regular basis. Internal command are the part of command.com. Some DOS internal commands are CLS used for clear the screen, VER used for version number of DOS command, DOS, VOL display the volume label and serial. Type, it is display the content of a text. Exit command is used to exit process. And some external DOS command. Second type of DOS command is external command. DOS external command are required less frequently. They are reside on disk, loaded automatically into memory RAM only when you needed. Some example of external DOS command. chkk check the validity of the disk and reports the total space, number of files, and automatically and amount of free space. COMP compare the content of two set of files. And command start the command processor. SYS create a bootable drive. Thank you so much.
Okay. Now open the video. Okay. Now close it. Once Saxena, are you ready now?
Yes, sir. So there was some
Okay.
network issue at that time, actually.
Okay, no problem. Now share your screen and
Okay.
start the presentation.
So please let me know if my screen is properly visible. I'm audible too.
Yeah.
Okay, thank you, sir. So directly, I'm starting with my intro. So welcome, guys. Good morning, sir. I'm Van Saxena, and here I'm going to present my computer fundamental assignment presentation. So the topic before my hand is to explain number system and a Python code to perform conversion of binary, octal, and hexadecimal number to decimal number system. I'm here writing a Python code. So directly moving on, let's first discuss about what's a numbered system, because when we to go to the insight of what's going on through the program, we should know about the number system. So directly moving upon binary number system. A binary number system is a number system expressed in a base 2 numeral. Or binary number system is a method of mathematical expression which uses only two symbols, typically 0 or 1. And in physics, we call it as high volt or low voltage. There is only two things. The digit in a binary number is called a bit. Computer use binary number system to manipulate and store all their data, including numbers, words, videos, graphics, and musics. A byte is a group of 8 bits. A kilobyte is 1024 and bytes or 8192 bits. That's multiplied by 2 only. Multiplied by 8 only. Now, few rules and facts about binary number that you must know that. So, I have mentioned the following example which illustrate conversion of binary to decimal number system. We can, as we can see here, we are performing calculation by multiplying it with the 2 power 0, 2 to the power 1. Similarly, we go to 2 power 10. And after all the calculations, we are just adding them. This is how to convert to binary number system to a decimal number. Here are few rules that I have mentioned here of addition, subtraction, multiplication, division. The very exceptional thing that we must know that 1 plus 1 is not equal to 2 in binary number system because 2 does not exist in whole binary number system. 1 plus 1 equals to 0 and carry upon 1. And similar thing with subtraction, we go to where 1 minus 0 or 10 minus 0 is equal to 1. Because here also no other digit is given except 0 and 1. Now directly moving upon octal number system. So let's first briefly discuss about octal number system. So a number system which has its base at is called as 8 is called an octal number system. It uses number from 0 to 7. Let's take an example to understand the concept. As we said any number which base 8 is an octal number system. That's like 248, 1098, 558, etc. are not octal number because they have their digits with 8 and 9. Now advantages of octal number system. The main advantage of using octal number system is that it uses less digits than decimal and hexadecimal number system. So it has fewer computations and lesser computational errors. It uses only 3 bits to represent any digit in binary. Now what's the application of number system that we must know there? That octal is used when the number of bits is one word is a multiple of 3. It's used as a shorthand for representing file permissions on Unix system and representation of UTF-8 numbers, etc. Now continuing upon hexadecimal number system. So hexadecimal number system is one type of number representation technique in which values of base 16 are used. It means 16 symbols or possible digit values. There are 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and A, B, C, D, E, F. Here a few alphanumeric numbers are also mentioned. Where A, B, C, D, E, F are single bit representation of decimal values 10, 11, 12, 13, 14 and 15 respectively. It requires 4 bit to represent. Hexadecimal number system provides convenient way to converting large binary number systems into more compact and smaller groups. Since base value of hexadecimal is 16, so there are maximum value of digit is 15 and it cannot be more than that. Now we have looked upon, summarizedly we have looked upon the number system. Now it's time to moving on to the very next part. So here comes the Python code to convert binary, octal and hexadecimal number system to decimal number system. This is what our main objective to find that. So before going on the code, I would like to discuss what I have used in my Python code so that you can have a quick and very good insight what's going throughout the code. So I have used properly comments. Proper comments have been provided at every moment so that the user can find it easy to understand, and proper documentation also mentioned there. I have also used loops to perform calculations which are repeatedly occurring calculations to perform. I have used loops such as for loop and while loop. I have used lists and dictionary. Lists are used to perform calculation with the single digits of binary number or octal number or hexadecimal number. And dictionary I have used to allocate alphanumeric values to their numeral values such as A to 10, B to 11 and similar so on. I use try except block to handle errors caused by system because of error program, so that we can manipulate the errors and give as per our reason. I use function so that if we need any block of the code to repeat it again and again, so I have mentioned function there. Now it's time for Python code. Sir, I would like to view this code on Python shell. Can I?
Okay, Samadhi, but if you make this larger one, it's
Sir,
good.
excuse me, sir.
It is not visible clearly. Okay, but if you want to make it some large part,
Excuse me, sir. Sir, am I audible?
you are audible.
Hello, sir. Am I audible, sir?
Yeah, yeah.
Okay, sir. I
Okay,
will
now
show
we,
this code and output on the Python shell itself. So this is
okay,
what code I'm going to describe on the very next minute. This is the second page of code, and now it's time to go for the code output.
yeah,
This is what the code output, and I'll also show this code output on the Python shell itself, because there it will be more precise and will be a better understanding will be created there.
okay,
So it's end of the slide. Thank you so much. So moving upon the code.
okay. Now open your video.
This is what our code is. I have started my code using function checkInt. Here I have check if my number given is in integer form or not. If it's not in integer form, I am neglecting giving a reason that not a valid number or system cannot perform with given number. It means I am only considering integer number. I am not considering any float values or decimal values. So I have checked here, if integer value is greater than 0, then it will return 0, and if not, then it will return 1. And if it will return 1, this means number is not an integer, and I will print that system cannot perform with the given number. Now there I have created another function, that's bin for conversion values, and here we will see what's going on. I've created first a list. What's the number? If the number given by user, suppose I have given number any number that is binary number, then it will create a list for that, so that we can perform calculation manipulation on every single digit of that number. And I have performed loops and checked in binary. If a is equal to 1, that means a number is binary. If choice is given from binary to decimal conversion, then I'm checking if binary number is given or any other type of number is given. If digit is containing only 1 or 0, then I will pass. And if any other digit have been given, then it will be giving error, that's invalid binary number system is showed. Now if we'll take the choice, suppose I am taking from octal number to decimal number system conversion, then I'll give a is equal to 2, and after a is equal to 2, it means our b value is 8. So I will check if our given number contains only 8 or 0. 8. If our number contains 8 or 9, it means invalid octal number. It means our number should contain only 1, 2, 3, 4, 5, 6, 7 only. Now similarly, I have checked for a is equal to 3 hexadecimal checks, and I have used hexadecimal checks because it would take some also alphanumeric. So I have separated it in a different block. If a is equal to 3, I will first check number is greater than 0, then pass, and then I will check if number is less than if number is means lie between a to f. The alphanumeric part lies between a to f. Then it will pass, else it will print invalid decimal number, as I have discussed here. It means the ordinate part, ordinate is the ASCII code of a, that is capital A 65. It is less than that ordinate code, then it will give invalid number, or it will greater than 70 yani ki f, then it will also give invalid hexadecimal number. Now the most important, the most manipulated calculation, I think so, that I have performed here is like this, using this loop. Here I have looped and performing necessary calculations, which is the very key factor. This is the very important line master stroke of this program only. Now, at last, after calculating the number, that's G. Now I am printing the number in the decimal is G. This is the very start of program. Every number to binary decimal converter. Then this is all the very, interpretation of the program. Here I have made user to enter the choice. Then after choice, as per 1 or 2 or 3, the user will give the number and will perform necessary checks, like we are checking the if number is integer or not. If choice is A or 2, then I will check and perform calculations.
Okay, Bans. Okay.
And
now
after that,
good job.
program will be terminated.
Okay.
Let's directly move upon what's going on to the program, so we can have a better understanding.
Okay, Bans.
So,
Now you have done the good job. Okay. Now close your presentation.
After running the program, this is how my output part of that program looks like. So every number to binary conversion,
Okay.
press 1 to convert from binary to decimal, press 2 to convert from octal to decimal, press 3 to convert from hexadecimal to decimal. So regardless of anything, I am pressing just 1. Choice is 1. Now I'm entering, I have to enter a binary number. Let's say I'm not giving a binary number, I'm taking any different kind of number, 1052. Then invalid binary number is shown. Now, want to perform more calculation, enter 0 for yes and any other key for no. So enter choice for continuation, I am entering 0 because I want to perform more calculations. Now enter choice as per, I am giving 1 because I want binary to decimal conversion. Now I am giving a binary number that's pure binary and it will not give any error, I bet. So number in decimal is 11. So want to perform more calculation, that's again, I want to perform more calculation, that's 0. Now I want to enter a choice, that's let's say I'm now converting from octal to decimal. So I'm giving a choice 2. Now I am giving 1096, which is not a valid octal number because it contains digit 9. Now again moving, I'm also continuing the program. So 0 for yes and other key for no. I'm not going to terminate the program. Again, I'm giving the choice 2. And here I'm giving a perfect octal number which could not create any error. So the decimal number of this octal number is 523. Similarly, moving upon, let's take a more example. I'm taking a decimal values like this. Then it will give an error, not a valid number, or system cannot perform with given number. Now I'm taking hexadecimal checks, that's choice 3. Here I will mention a pure hexadecimal number, and I bet there will no error be caused. So the number in decimal is 14,563. Want to perform more calculations? That's completely yes. So here choice I am giving 3, and now I am giving I and valid hexadecimal number because I mentioned alphanumeric number as I, and let's see what happens. It gives invalid hexadecimal. And I think it's time to terminate the program. So let's give another key so that it can terminate the program. And hence, program has been terminated. That's the end of my program. Thank you so much.
Okay, thanks. Once you have good tried. Now open your video. Okay.
Well done.
Excuse me, sir.
Yeah,
Actually, your
open
voice.
video.
Okay, sir. Okay, sir.
Okay, good. Now close it. Thank you.
Thank you, sir. Thank you.
Okay. Now next one, Manvi Kashyap. Manvi, are you here? Manvi, can you hear me?
यस सर। सर मेरी वॉइस नहीं आ रही क्या आपको?
यस नहीं आ रही थी तभी तो, अब तो ठीक है, चलिए ठीक, ओके नाउ स्टार्ट।
सर ये लग रहा मुझे हो नहीं रहा है। सर मुझे लग रहा है मेरा नेट ठीक से काम नहीं कर रहा, किसी और
ठीक है, ओके, अपने मोबाइल को चार्ज में करिए, ठीक है।
बैटरी भी बहुत कम है।
नाउ नेक्स्ट वन, सावंत मिश्रा।
Yes, sir.
सावंत मिश्रा, आ रही है?
Yes, sir. Yes, sir.
ओके नाउ यू स्टार्ट।
Is my screen visible, sir?
या
Okay, sir. Good morning, all of you. I am Savant Misra, and today I want to introduce the topic of simplification of Boolean expression. And so, firstly, we have to know about what are the methods to simplify the Boolean expressions. So there are three methods to simplify Boolean expressions. First is algebraic simplification. Second one is K-map simplification. And third one is Quinn-McCluskey method of simplification. So firstly, we have to know about the what is algebraic simplification of Boolean expressions, and here we only studied about the algebraic simplification. So how to simplify the algebraic simplification? So here the first step is bring the given expression into sum of product form, or we can also set that SOP form by Boolean laws and De Morgan's theorem. And the second step is that we have to simplify SOP expression by checking the product terms for common factor. Now we have to know that firstly, what is the sum of products expression? So the sum of products expression is a single product term, which it can be also said that min term, or several product terms that we also say that min terms logically added, and we can also say that ORed together. And the example of sir, am I audible?
Yeah.
Okay, sir. So, and the example of sum of product expression is that x dot y dash plus x dash dot y is an example of SOP expression, or we can also say that x dot y or the laws of Boolean algebra. So here also the commutative laws. So first commutative law is a dot v is equal to d dot a. That means if we multiply the two binary variables, that means a into v, then if we multiply in it reverse order, that means firstly we multiply b with a, then they gives equal values or the same values. And the second law is that a plus b is equal to b plus a. So here we also say that if we add the ordered the binary variables in reverse order and normal manner, they are equal. So, and the associative law, according to the associative law, a dot b into c is equal to a dot b dot c. And the second part of associative law is also said that a plus b plus c is equal to a plus in bracket b plus c. Now in the distributive law, a dot b plus c is equal to a dot b plus a dot c, and the second part of distributive law is a plus b dot c is equal to a plus b dot a plus c. So in distributive law, all the binary variables have to expanded them. And by the absorption law, in absorption law we have see that the a plus in bracket a dot b is equal to a, and the second part of absorption law is a dot in bracket a plus b is equal to a. And here are some also special laws in Boolean algebra. A plus ab is equal to a, and second law is that a plus a dash b is equal to a plus b, and third law is a plus b into a plus c in bracket is equal to a plus bc. And according to AND law, a dot 0 is equal to 0, a dot 1 is equal to 1, and a dot a is equal to a. And a dot a is equal to a, we can also say that it is a idempotent law. And a dot a dash is equal to 0, it can be also we say that complement law. And OR law, according to OR law, a plus 0 is equal to a plus 1 is equal to 1, and a plus a is equal to a. Idempotent law according to, and a plus a dash is equal to 1, complement law. Inversion law we can also say that inversion law is a involution law. So here a double dash is equal to a, that means if we complement twice time, then we get the normal binary variable. So now we moving to De Morgan's theorem. According to De Morgan's theorem, x dot y whole complement is equal to x dash plus y dash. and second part is x plus y whole dash is equal to x dash dot y dash. Now, if we have to simplify the Boolean expression, then we have to solve the Boolean expression in preference wise. Firstly, we have to solve that expression which is written in the parenthesis, and then we have to go the part which is in not part, which we also called as a not part. That means the complement part. And then we have to go to the end part. That means the part which is in multiply with binary variables, and then we have to go to that part which is in add which where we add the binary variables, or we also say that in logically added or ORed the binary variables. Now here we see the some expressions of Boolean algebra which we have to simplify. So here one of the question is that using Boolean algebra techniques, simplify this expression AB plus A in bracket B plus C plus B in bracket B plus C. So here we have to simplify by using the Boolean algebra. So here firstly we have to expand all the expression by AB plus and ended the part which is in bracket with the binary variable outside the bracket, that means A. So here AB plus AC plus BB plus BC. Okay, so then the next step is that AB plus AC, and here B dot B is equal to B, because if we multiply if we ended the same binary variable, then we get the binary variables, single binary variable plus BC. Okay, now the third step is that AB plus AC plus B plus BC. So here is also said that if we ORed, or we can also say that if we logically added AB plus AB, if we logically added the binary variable, then we get the same binary variable. So here AB plus AB is equal to AB. Now the fourth step is that AB plus AC plus B. So here we also are some special law is that the if here x plus if we take the some generally binary variables x and y, and if x plus xy is in the case the any expression, then we get the value x. So here we similarly also see that B plus BC is equal to B. So here now the fifth step is that B plus AC finally simplify. So here we see that the AB plus B is equal to B, which is like the fourth step. So this part is solved. Now we go to the next question. So here we also minimize the following Boolean expression, which is given the f of a comma b comma c is equal to a dash b plus b c dash plus b c plus a b dash c dash. So here we have to solve that. Firstly we have to a dash b plus b c dash plus b c dash. Yeah, here we again add the b c dash, and because we add here we use the idempotent law, because in idempotent law if we add the same binary variables, then we get the same value. So bc dash plus bc dash plus bc plus ab dash c dash. Now we go to the next step, a dash b plus bc dash plus bc, and then if here we take the bc dash with bc and the other bc dash is with ab dash c dash, and now we go to the third step, a dash b plus, here we take the b common in bc dash plus bc, so it is remain in bracket c dash plus c, plus here we take the common in next expression c dash, so here it is remain that b plus ab dash. Now in fourth step, a dash b plus b dot 1, because if we if we add the binary variable with its complement, then we get the value 1 plus c dash into b plus a. Now in fourth step, b plus c dash into b plus a. So we also know that 8. Yeah, here also like the same property follow. Here we also take the common b. So we also say that if we add the any complement with 1, then we also get the same value 1, and then b plus bc dash plus ac dash. Here we expand the expression, and we firstly then take the common b 1 plus c dash plus ac dash, and then we find the finally b plus ac dash the right answer. So here now the next question is that c plus bc whole dash. In here we firstly use the De Morgan's law. Here the De Morgan's law, c plus b dash plus c dash, and then the third step is that c plus c dash plus b dash. Here we use the commutative law and also associative law. And the fourth step we use the complement law, 1 plus b dash, and finally we get the value 1. Now now you see similarly the fourth question is also. So in here we also solve by using the same Boolean laws, by using complement laws and commutative laws, associative laws, and many other laws, and simplify this, and we get the finally answer b plus ac. And that's all. Thank you.
Okay, good. Now open your video. Okay. Now close it. Next, Shivam Kharwar.
Yes, sir.
Now start your presentation.
Sir, am I audible?
Now it is visible.
Okay. Can I start?
Yes.
Okay. Good afternoon, everyone. I Shivam Kalap is the first semester. I am here to present my presentation on topic simplification of Boolean algebra using Karnaugh map. Introduction. The Karnaugh map or K-map is a method of simplifying Boolean algebra expression. Maurice Karnaugh introduced it in 1953. The K-map is a systematic way of simplifying Boolean expression with the help of the K-map method. We can find the simplest PO as product of sum and SOP sum of product expression. Like the truth table, a K-map contains all the possible values of input variables and their corresponding output values. However, in K-map, the values are stored in cells. In each cell, a binary value of each input variable is stored. Let's us discuss about sum of product. It is one of the way of writing a Boolean expression. As the name suggested, it is found by adding the product terms. These product terms are also called as minterms. Minterms are the product of Boolean variables either in normal form or complement form. For example, in this example, we have three variables A, B, and C. The minterms in this are A dot complement of A dot complement of B and C. SOP is formed by considering all the minterms whose output is high. While writing minterms of SOP, input with value 1 is considered as the variable itself, and input with value 0 is considered as complement of the input. Now, product of sum or POS. As the name suggested, it is formed by multiplying the sum terms. These sum terms are also called as max terms. Max terms are the sum of Boolean variable either in normal form or complemented form. For example, here three variables are A, B, and C. A is 0, B is 1, and C is 1. So the max term will be A plus complement of B plus complement of C. POS is formed by considering all the max terms whose output is low. While writing max terms for POS, input with value 1 is considered as the complement and input with value 0 is considered as the variable itself. Now here are the groupings rule for K-map. Group must contain 1, 2, 4, 8 or in general 2n cell. That is, if n is equal to 1, a group contains 2 ones. You can see in the figure here we have two group of ones. Similarly, each group should be as large as possible. Here in the figure we can see we have four group of ones in two groups, not of two groups 1 in 3 pair. Next is groups may overlap. We can overlap the groups to form the maximum number of groups. Next is groups may wrap around the table. The leftmost cell in a row may be grouped with the rightmost cell, and the top cell in a column may be grouped with the bottom cell. Next, there should be a few groups as possible, as long as this does not contradict any of the previous rules. Let us consider an example. In this example, we have to plot a three variable map for the function f is equal to complement of A dot complement of B into complement of C plus complement of A complement of B C plus A into complement of B C. For mapping, to draw the K-map for this function, here we can see that we have three variables A, B, and C. So the number of cell K-map will contain is 2 to the power n, where n is number of create 8 cells. Here we can see we have 8 cells here. Now, as we discussed earlier in SOP, A is considered as 1, B is equal to 1, and C is equal to 1, and its complements are 0, which is denoted by A dash. So here, in the first expression, it is complement of A dot complement of B dot complement of C. So A complement is 0, B complement is 0, and C complement is 0. So to plot this in the K-map, here we see this is AB group and this is C. In here we have A complement and B complement. So here its value is 0, 0. So we check in AB group 0, 0. So here we get a 0, 0 value. Similarly for the C, we also have C value 0. So in C this is 0. So we get this cell for this input. So we will mark it as 1. Similarly for the rest, we also mark 1 and 1 here. Now we have to do the grouping. So we have grouped this one red one group and this one yellow group. On solving the red group, we get A complement of A and complement of B. And solving the yellow group, we get a C into complement of B. Now, as it is sum of products, so the final answer will be the sum of these both. So the final answer is F is equal to complement of A into complement of B plus C into complement of B. Thank you, sir.
close it and open your video.
Okay.
Okay. Now next one, Amit Kumar. Amit Kumar is here. Next, Shivam Tripathi. Shivam Tripathi.
Yes, sir.
Now start your presentation.
Yes, sir. Good morning, sir. Myself, Shivans Tripathi. I am presenting the given topic, logic gates and its application. Sir, logic gate. Sir, it is visible or not?
Yeah, now it is visible.
Sir, logic gates is a signals that are operate. Sir, is my voice audible or not?
Yeah, audible.
So logic gates are or operations that are means of combinations of signals passing through standard bills of blocks of built-in circuit known as logic gates. So basically, they are signals that used to produce standard output, and these are building blocks of the electronic circuits in a computer. So some of important logic gates are as follows. First, AND gate. This gate is a physical realization of logical multiplication. It is an electronic circuit that generates an output signal of 1 only if all input signals are also 1. Basically, it tries to says to mean that if any input is given and it's any two of inputs are false, then it relatively to be false, and if all the inputs are true, then it will only shows that it will be true, or output will be 1. We can see through it blocked truth table for AND gate. Here the input are A and B, both are 0, where output will be 0. If any one of the both of them will be 0, then A and B will output will be 0, and if both of them will be true, then the output will be 1. From the next, OR gate. An OR gate is a physical realization of logical addition or operation. It is an electronic circuit that generates an output signal of 1 if any of input signal is also 1. From here, we can see in the truth table that if both the inputs are 0, the output will be 0. If any one of the input will be true, true, their output will be 1, and if both are true, then it will be 1. Where C equals to A plus B, that is from relation. Now NOT gate, it is a physical realization of complementation of operation. It is a circuit that generates the reverse of input signal as an output signal. It is also known as inverter because it inverts output. Basically, in simple word, it is an inverse function in logic gates. NOT gate is basically at a inverse of what has been be input. We can see in the truth table that whenever we put input as a 0, basically as a false input, then output will be 1, and when we make the input true, I1, the output will be 0. Next gate is the NAND gate, and it is complemented gate AND gate. That is, the output of NAND gate will be 1 if any one of the input is 0, and it only be 0 when all inputs are 1. We can see in the truth table that when the both inputs are false, I0, the output will be 1. If any one of the inputs is true, then the output will be 1, and if both inputs are true, then output will be 0. Next gate is the NOR gate. It is a complemented OR gate. Here's the output of NOR gate will be 1 only when all the inputs are 0, and it will be 0 when if any input is 1. Basically, it is a reverse of NAND gate. Here's if both input are 0 or false, then the output will be 1. If any one of the inputs are true or 1, then the output will be 0, and if both inputs are 1, then the also output will be 0. Now these are two another operation which are based on the gates. Basically, it's an exclusive OR operation. In this operation, output is normally at logic level 0 when both inputs are same, and goes to logic level 1 when any input differs. Here, where you can see in the truth table, if both the inputs are 0, then the output will be 0. If any one of the input is 1, then the output will be 1. And if both inputs are true or 1, then the output will be false. And this last one, this is an exclusive NOR or equivalence operation. Basically, this exclusive NOR gate is a combination of the exclusive OR gate and the NOT gate, where input is normally at logic level 1, and when both inputs are same and goes to logic level 0 when any of its input differ. Here we can see inputs when in the truth table, when both inputs are false or 0, the output will be 1. If any one of the inputs is false, then output will be false, and if both the inputs is true, then output will be 1. Thank you, and I rest my presentation.
Open your video. Shivans? Yes. I think you have joined in last, है ना? आपकी आवाज नहीं आ रही है.
Yes, sir, I have joined at last.
Last, na? That's why your name is not in my file, and I have written here. Okay. And you have submitted your assignment?
Yes, sir.
Okay.
So assignment that has to be on Gmail. I was not there. Came at last, and I am only designed this presentation only.
Okay, you can send this presentation as well as your assignment on my email spkanoji@gmail.com.
Okay, sir.
Okay. Now close it.
Okay, sir. Thank you, sir.
Okay. Next one here, Prakash Chaurasia.
Yes. Yes.
Now your presentation is okay now?
Yes, sir.
Now we start. Okay. Now start your presentation. Next, Manvi Kashyap. Are you ready?
Sir, those who don't have to give presentation today, can they leave?
Acha, acha.
So can I start?
Yes, yes.
Okay, so you already know my name, so I'm going to start again. So here's my presentation on analog and digital computers. So computer is a beautiful thing. You already know how they work, but I'm going to give you a little discussion on digital computers and analog computers. First of all, let's talk about digital computers. The computer on which you are listening my voice is a digital computer. They convert data into bits that are zeros and ones. Today, most of the computers used by individuals or business organizations are digital computers. Reason being, they are very accurate and very fast in speed. Then we have analog computers. Analog computers store data in the continuous form of physical quantities and perform calculations with the help of measures. Analog computers are the earliest computer. Today they are largely replaced by digital computers because of their less accuracy and low speed. Here we have the very basic example of analog computer. So if we move the black wheel here by 5 units and then the white wheel here by 4 units, we can see the result in the gray wheel, which shows which is rotated by 9 units. So this is a basic analog computer which works by gears. Then we have the example of a basic digital computer. Digital computer takes inputs in bits. So we have 2 bits which represents zeros and ones. So now they are off. So 0 plus 0 equals 0. Then 0 plus 1 equals 1. And 1 plus 1 equals 1 0, which is of course 2 in decimal digits. Then now let's give a brief comparison of analog and digital computers. Analog computer works with continuous values while digital works with discrete values, zeros and ones. Analog has no state while digital has state on and off, 0 and 1. Analog has very limited memory while digital can store large amount of data. Analog is very fast while digital is comparatively slower. Sorry, I just said the opposite. Digital is very fast while analog is comparatively slower. Analog is less accurate comparatively to digital. The examples of analog computer are thermometer, analog clock, older weighing machine. Digital computers, we have digital watches, digital weighing machines, mini computers. Let us give a brief look in our past. As I told you, past computers were mainly analog. In 1901, this ancient Greek artifact was discovered in a shipwreck of the island of Antikythera. The radiographic images have showed that the remaining fragments contain 30 gear wheels. No other geared mechanism of such complexity is known from the ancient world. This is of course not a digital computer. It works by analogy. Their gears are constructed in such a way that they are analogous to the motion of sun and moon, and this is the analog computer. Then we have the difference engine that was built by Charles Babbage. Then we have the first modern analog computer, a tide predicting machine. It was invented by Sir William Thomson. Then we have the replica of JUICE Z3, the world's first electrochemical, programmable, fully automatic digital computer. There the era of digital computers started. Then this is Colossus electronic digital programmable computing device. Then we had ENIAC, the first electronic tuning complete device. Then in modern era, you see now nowadays we don't use the analog computer. We use digital computers. The reason is the rise of transistor. In past times, we mostly had analog computers, but they were not very fast in speed. This changed with the rise of transistor in the modern era. From 1955, they replaced the vacuum tubes that were previously used in the computer design. We got integrated circuits too. It's a set of electronic circuits on a very small chip. This is the reason why we have computers in our pockets nowadays. So one more and very important reason which led to in the rise of digital computer was the introduction of Moore's law. It's not actually a law, but an observation which was given by Gordon Moore that the number of transistors in a dense integrated circuit doubles about every 2 years. So it continues to stand as a technological benchmark for the semiconductor industries. One of the economic impacts that you can see of the law is that computing devices continue to show exponential growth in complexity and computing power while effecting a comparable reduction in the cost to the manufacturer and consumers. So I would like to conclude this presentation by giving you a topic to think that what is the future. Some physicists say that the Moore's law is breaking down. We have already seen the slowation in the Moore's law, and some people think that it might end in 10 years or so. We have we have the other options like molecular transistor, quantum computers, and we may see a comeback of analog computers in upcoming days. That was all for my presentation. Thanks. So
Okay, now open your video.
Sir, excuse me.
Open your video. Okay, now close it.
Sir, excuse me.
Yes.
Sir, can we leave, sir? Sir, those who don't have to give presentation.
I'm just taking your attendance. Little bit, stay little bit here. Okay. क्या कोई दूसरी क्लास चल रही है?
No, sir, mathematics class will start at 2, but sir, it's been 1 hour 40 minutes since we have started this.
Okay. Now Anchal Kushwaha. Here Anchal Kushwaha.
Yes, sir. Present, sir.
Okay. Aditya Jaiswal.
Present, sir.
Next Akash Verma. Okay. Alok Bhaskar.
Yes, sir.
Next Astha Asthana.
Present, sir.
Next Ayush Kumar Mishra.
Present, sir.
Next Kanchan Saxena. Manvendra Pratap.
Present, sir.
Manvi Kashyap.
Present, sir.
Meenakshi.
Present, sir.
Neeraj Mishra.
Present, sir.
Ayush Mishra.
Present, sir.
Ayush. Next Pragati Mishra. Pragati Mishra.
Present, sir.
Prakash Chaurasia. Prince Gautam.
Present, sir.
Next Rafif.
Present, sir.
Okay, next Rishi Srivastav.
Present, sir.
Next Sachin Tripathi.
Present, sir.
Okay. Next Sawant Mishra.
Sir, Kanchan.
Present, sir.
सावंत मिश्रा. कंचन हो गया आपका.
Okay.
शिवम खरवार.
Present, sir.
ओके. शिवम सिंह कुशवाहा.
Present, sir.
श्रेया अवस्थी.
Present, sir. Present, sir.
सिद्धार्थ. ओके. सिद्धार्थ.
Present, sir. Present, sir.
सृजन श्रीवास्तव.
Present, sir.
वंश सक्सेना, ओके।
Present, sir.
नेक्स्ट, ओके, विकास चौहान,
Present, sir.
ओके, सबका हो गया। एनी मोर, कोई बचा तो नहीं?
Sir, my name is Shivansh Tripathi.
हाँ, ठीक है, हो गया। देयर इज वन इंफॉर्मेशन फॉर यू। दोज स्टूडेंट हु हैव प्रेजेंटेड देयर प्रेजेंटेशन, प्लीज सेंड ऑन माय ईमेल, ओके। आप उसको ईमेल पे भेज दें।
Sir, I
और
have sent
दूसरी
it.
बात, हाँ ठीक है, ओके। जिन लोगों ने भेज दिया वो रोज मॉनिटर हो जाता है, ठीक है। तो दूसरी बात यह है कि आपका जो फर्स्ट सेमेस्टर का कोर्स है, जो अभी तक आपका चल रहा था, उसमें थोड़ा सा परिवर्तन हो रहा। ये हो रहा है कि नेक्स्ट सेमेस्टर की क्लासेस स्टार्ट हो रही हैं, ठीक है। तो आप लोग नेक्स्ट सेमेस्टर में एक तरह से मान के चलेंगे कि इसकी क्लासेस आपको करनी है अब, ठीक है ना। और उसके एग्जाम्स जैसा कि यूनिवर्सिटी ओपन होगी तो होगा, या जो भी गाइडलाइंस आगे आएगी उसके अनुसार होगा, या हो सकता है जो भी सिचुएशन है उसके अकॉर्डिंग। तो अब इस कोर्स में जो कुछ भी आपको लगता है कि और पूछने की ज़रूरत है, तो किसी भी टाइम आप लोग पूछ सकते हैं, ठीक है। मैसेज कर दें, हम एक टाइम बना देंगे, उस टाइम आप लोग इसमें डिस्कस कर सकते हैं। और जिन लोगों का प्रेजेंटेशन छूट गया है उसके लिए मैं आपको एक मैसेज दे दूंगा, जिस समय मैं खाली रहूंगा। बाकी अन्य लोगों का, ठीक है, कल मैं प्रेजेंटेशन ले लूंगा। तो ये ध्यान रखें कि मैक्सिमम लोग कल देने की कोशिश करें, ठीक है ना।
Yes, sir.
One doubt.
क्योंकि
फर्स्ट सेम
हाँ,
का
जो
Sir, will the
आपकी
exam
क्लासेस,
will be conducted or not?
अभी तक कोई क्लेरिफिकेशन नहीं है। हाँ, क्लेरिफिकेशन ये मेरे पास आ चुका है कि आपके सेकेंड सेमेस्टर की क्लासेस स्टार्ट कर दी जाए, ठीक है ना।
सर एग्जाम कब तक होना
Okay,
है?
sir.
अब कुछ नहीं बता सकते बेटा, अभी तक हमारे पास एग्जाम का कोई इंफॉर्मेशन नहीं आया है, ठीक है ना। बट प्रिपेयर फॉर दिस वन, उसके लिए तैयार रहिए, हो भी सकता है, ठीक है ना। लेकिन आगे की जो क्लासेस है वो कंटिन्यूअस, जो आपके टीचर अलॉट होंगे वो आपकी क्लासेस लेते रहेंगे, ठीक है। और इस प्रेजेंटेशन को मैं कल जो है सबका फिनिश करना चाहूँगा, तो मैं आपको एक डेट टाइम बता दूंगा, ठीक है, जब आपकी क्लासेस नहीं होगी। आई थिंक, ठीक है ना, अगर कल
सर
सेम टाइम
सेकंड
पे
सेमेस्टर
अगर
की
हो
क्लासेस
पाएगा।
कब से स्टार्ट होनी है?
आज से ही स्टार्ट हो गई हैं, ठीक है, कुछ जगहों पे हो गई हैं। और आप लोग कल से या आज से भी स्टार्ट देख लीजिएगा, आपके पास लिंक जाएगा, ठीक है ना। जो
सर
कंसर्निंग
अभी
टीचर
तो
होंगे,
हमारा किसी भी सब्जेक्ट में पूरा कोर्स कंप्लीट नहीं हुआ लेकिन
हाँ, अब यूनिवर्सिटी का ऐसा गाइडलाइन से क्या किया जाए, तो सभी लोग चाहे फिजिक्स के हों चाहे मैथ केमिस्ट्री, सब लोग साइड बाय साइड वो स्टार्ट कर रहे हैं सेकेंड सेमेस्टर का, ठीक है। तो इस कोर्स में जो भी बाकी जो रेस्ट ऑफ द छूटा है, अगर आप लोग पढ़ेंगे, अगर कोई दिक्कत है, ठीक है, बाकी सबका प्रेजेंटेशन होगा ही, उसमें अटेंडरी उसमें हो जाएगा, ठीक है। और जो अगर आपको लगता है कि पूछने की जरूरत है तो आप हमसे डायरेक्ट पूछ सकती हैं, ठीक है।
ओके सर।
हाँ, ठीक है। तो नाउ इट इज टाइम टू लीव आउट।
थैंक यू सर।
ओके,
Thank you, sir.
ओके।
Thank you, sir.
Sir, Himanshu attendance